So what's going on, my viewers and subscribers? To all my Jamaican people, what has been going on? I know some of you have been going through a rough time due to the passage of Hurricane Mellisa, right? And my thoughts are with you. I hope that you are persevering, going through the daily struggles. That we Jamaican people, we African people. We know how to get through these trials and tribulation. We have been through 400 years of slavery and colonization. So, we know how to get through this one. And I see that we are putting hands and heart together and we are assisting each other on the ground to cope with this, you know, enormous catastrophic devastation of our little island, Jamaica. You know? So, yeah, man. So, I'm truly with you in heart and in spirit. Yeah. So in today's video, I want to address something. We have been observing a rise in water level in Content, Manchester, right? And this is not something that has been happening for the first time. I live in Manchester, okay, Christiana to be exact. All right, and this is not the first time. I remember when it happened in 2002, you know what I mean? I was stationed at the Manuel Fire Station then, and every day when I was going home, I would stop by and look, and people would gather there and look, to the rise of water. And it's not only content either. Water has been rising right at the foot of Melrose Hill, right there from the foot of Melrose Hill, entering Pores, you know, and all of those areas natural spring have been broken out and it was quite an attraction, and I know that it wasn't going to last for any period of time. As soon as the water level settle down, it's going to dissipate, but this time around, due to the passage of the hurricane, it has been rising and rising steadily. All right, but so I'm going to shed a little light on this. I'm going to use my engineering skills to talk to you about it. So I study hydraulics when I was doing my engineering course, and he just brought me back to look on some notes that I have in my notebook and to revisit my text. So this is a text here. This is Fundamentals of Hydraulic Engineering. So this is the book that I use in college, right, while I was studying civil engineering. So as I said to you before, as civil engineer, we study a wide variety of subjects, not only structures, we study about water, we study about, various things in the built environment. We study about earthquakes too, and geology, we study the rocks, and those things. So today's video, I'm going to shed some light on that topic. I'm going to give you a scientific explanation as to why we have been faced with these problems. As I said, it's not the first time. I live in Christiana and I have seen it before, and it's nothing strange to me. All right, so I'm going to shed some light on it and the reason why it happened from a scientific and an engineering perspective. All right, before I get into the presentation, I just going to give you a little introduction about water. All right, because many people see water and they do not know the full characteristics of water if you're not trained as a civil engineer in the field of hydraulics and hydrology. All right. So, water, when pure, is colorless and odorless. All right. Water, when pure, is colorless and odorless, and it takes the shape of any container that it is poured in, and it comes to rest at a level surface. All right, so that is water. All right, now when you see the term hydraulics, okay, when we talk about the study of hydraulics, we are talking about the study of water, whether in motion or at rest. Okay? So whenever time You see the term, let me repeat, whenever time you see the term hydraulics, it means the study of water, whether in motion or at rest. Okay? So that's the basic characteristics of water. Okay? And the reason I'm going through this, I want to give you a basic understanding of water. Another critical characteristics of water, just like any fluid, is that it flows. It flows from a region of high concentration to a region of low concentration, otherwise known as the hydraulic gradient. All right. So the hydraulic gradient or the hydraulic head is when the water is at a certain height, flows down to a low level because it is pulled by gravity. So if you're on top of a hill and you pour water on the ground, it has no other direction to go but down the hill because it is pulled by what? Gravity. All right. So when surveyors go out and do survey, they search in an area for a certain benchmark. Okay. And that benchmark is taken at a height above sea level. Now, let me give you some more explanation where that is concerned. Now, sea level, if the sea is calm and there's no wind energy blowing across the surface of the water, and the water is calm, the elevation is going to be zero. So if you're in a boat and you put a line at one point, at point A, and you stretch it all the way to another boat to point B, you're going to get no difference in elevation. The elevation is going to be zero. So if you put a, a monument in the water at a certain point and you stretch it 10,000 miles from here to Africa, the west coast of Africa to Japan, given that the sea is calm and there's no wind energy and the sea is perfectly calm, the elevation is going to be zero. And that's why surveyors, they use mean sea level to give us elevation, because the elevation on the surface of water is going to be zero. Okay, so if you fill a glass with water and you observe that glass with water, you will observe that it comes to rest at a level surface. The elevation is going to be zero. There's not going to be a difference in elevation from one point to the next point. All right. So you have to understand that conversation or that explanation that I'm giving to you to perfectly or somewhat understanding the presentation that I'm about to demonstrate to you. All right. Viewers and subscribers, so I've put together this sketch here today. I have looked in my engineering book and I have sketched out this cross section to demonstrate to you from a scientific perspective what is going on in content in Manchester. All right, so let me give you a preview of what is going on first before I get into the actual explanation. Right, so if you know Christiana, right, this is the picker pepper factory right here, right at Kendall Road, right? And if you come at the intersection of Kendall Road right there, if you make the left, you're going up Penhill, and if you make the right, you're going down to Penhill. You're going down to Windalco towards the Williamsfield roundabout. All right. So I'm just giving you a basic description. So this cross section here, right? So this is the road. This is the Penhill Road here. Right? So this is a road here that lead you to Christiana or Spalding. So if you notice, when you come on the main here, right at the picker pepper factory, you have a gradient, a hill. This hill is known as Penhill, a very steep hill that goes right up to Christiana. And when you reach the intersection of Walderston, you can make the right and that take you to Spalding's, all right, or Knox College. And you take the straight, go through Wallerston, it lead you up to Christiana. You pass through places like Shudley, Fine Grass, and then you reach Sedberg and then into Christiana main town. Alright? So that's a brief explanation. So it's a steep gradient that goes up to Christiana. It's what we call Penhill. Okay? Now, to give you a scientific approach, and by the way, this is a picture that I've gotten from online of the situation now. If you observe the height of the water, it virtually covers this building as I'm speaking to you. I'm sure you have seen images online. A lot of YouTubers have gone there to video and showcase what is really going on where water is concerned. Now, to give you the explanation now, so what we have, okay, whenever rainfall, right? So this is a rain. So this is the rain cloud here, okay. So when the rain falls, right, um, the water from the rain soaks down to the earth, right, and it goes all the way down. And by the way, if you observe that area, right, contents, the entire area is full of hill. Is almost hills. As far as the eye can see, it's pure hills that surrounds that area. Okay? And what goes on right here is that when you're coming from Christiana and you hit down right to the intersection of the Kendall Main Road, right, or the Picker Pepper Factory, the surface, the lands or the earth plateau into a level. Okay, so you're coming off a hill, a steep hill, and when you reach down to the Picker Pepper Factory, it plateaus and level off in a level area right towards Williamsfield roundabout. Right? So right at the level here, at the base of the hill, there's a natural basin or a natural valley that is being formed. Okay? And that's where the water is going to settle. Because when the rain falls now, all right, and it percolate down through the side to the hill, it comes all the way down to the confined aquifer here. Okay? And if you observe this cross section, right, is cut 100 feet. Because the reason why I have cut the cross section to show approximately 100 feet is because when we are doing boreholes here, when we are doing a bridge project, and we get the geotechnical unit to go and drill the soil, we usually drill approximately down 100 feet towards bedrock. Usually when we go down to 100 feet, we usually hit bedrock. It's a layer of rock, right, that you can't drill past. And usually when you drive the H pile down or the auger go down, you kind of refuse, you kind of reject the we call it refusal. You kind of reject the H pile or you kind of reject the drill, so we know that we hit bedrock. Okay, and that's usually somewhere in the region of 100, in some cases 110, 120 feet below ground surface. All right, so that is why if you observe here, let me zoom up a little bit. Right, you see here is approximately 100 feet. We get 96 feet too, but I was trying to get 100 feet really. All right, so it's 100 feet below ground surface, right? So here at 100 feet we have what is called bedrock or the impervious level. Okay, and above bedrock is what we call the confined aquifer. And the reason why it's confined to that area because the water is not going to be able to soak past the rock layer. There's some amount of percolation, but very, very negligible, very, very little amount of water. So the water usually stops right here, right at the rock here, and goes upward. So this is your confined aquifer here. The next level is we have low hydraulic conductivity, meaning that there's some amount of water that can seep through, but it's not as fast as when it reaches the confined layer. And up above the low hydraulic conductivity, we have the unconfined layer. Unconfined means that the water has no limit. It can go to whatever limit based on the amount of water that is soaking below the ground up above the hill coming down. All right. So what I want to get to you now. So this is the cloud, the rain cloud here. So when the rain falls, right, up the hill, right, the water is going to soak down, right? The water is going to soak down, and some amount of the water is going to go down the hill. It's what we call a hydraulic gradient. Some amount of it is going down the hill. But the reason when we get down here now and find that the underground, the confined aquifer, when that layer is filled, right? The water is going to what? The water is going to rise. Okay? Because it cannot go further down. And because the rate at which the water is soaking down to the earth, okay, is much faster than the runoff. Because when the water is soaking down here, it's going to run down the hill. Right? Some of it is going to tend to run down the hill as well. So it's going to soak down in the hill and run down like that. But the rate at which it is coming down is much faster than the runoff. And that is why you have a rise. So you can picture this. Say you have a bucket, right? You have a bucket and you punch at that bucket with a small little hole at the bottom. And you go to the pipe, right? And you're getting heavy water. The pressure is very, very high. Okay? You're going to find out that even though you puncture that small hole in the bucket is going to still fill with water based on the amount of pressure that is coming down through the pipe. Right? So the rate at which the bucket is filling, right, is more than what is going through the hole that you puncture. So the water is going to come up, irrespective of the hole that you puncture. So that's a similar situation here, right? The rate at which the water is soaking down the hill and moving down is much faster, so the water is going to rise. And when the underground aquifer is filled, right? When the underground aquifer is filled, the water has no way to go more than to rise, because the slope of runoff is much less than the rate of rise. Okay? So, in other words, so if you have here your natural water table, so this line here represents the natural water table. And if you notice, it's a straight line, right? A straight horizontal line, because I've said to you before, water comes to rest at what? A level surface. So this is your natural water table here. And when the underground aquifer is being filled and rise to the various level, the elevation is going to increase. So if you notice here, the rise in elevation here is above road surface. Okay? So this line here, right, represents the road surface, right? The road surface here, from this point all the way up to Penhill, all the way going up to Christian. I just cut a section through it, right, to show you. So in summary, the water that is going is landing on top of the hill in Penhill, in places like Christiana, Warsaw, Trelawney, all those rivers. When the water is soaking down through the natural ground coming down, it is coming from all the way up from Christiana, Sparlins, Trelawney, all the way up there. Because when you go through Christiana, it's mostly hill. And the water soak down now and come all the way down. And it plateau here, down in content. Right? Because down in content forms what? A natural basin or a valley. So the hill is like this, and they have a level off like this. So the water has nowhere to settle when it comes down from the hill, more than in the lower area here. And it's the same thing that happened on Melrose Hill. So it's not only contents, porous of the same thing as well, because the water soaked down through the hills of Melrose, come down to the lower parts of porous there, the natural basin. And that's where the water settled. And because the rate at which it is coming down is much faster than the rate at which it is running off. Right? And you have to remember now, all water runs to the sea. Why that is? Because the land is at a higher elevation than the sea level. Right? And remember what I've said earlier, that water runs from an area of high concentration to an area of low concentration. So that is why all rivers flows towards the sea, because the land is higher and the sea level is lower, so the water flows into the sea. All right. So I don't know if I've given you enough information, but that's the science behind it. So all that has happened in forest is that the underground aquifer here failed. And you have to remember now that 2-3 weeks before Hurricane Mellisa, right? There was a lot of rainfall in those areas, and there's a build-up of water over that period of time. And when we have Hurricane Melissa, it only compounds the problem. All right. So I've seen where people there is trying to cut drain to lead away the water. That doesn't make any sense, because wherever you lead the water is going to go back, because the entire area there, the underground aquifer is filled to capacity and it can't hold anymore. And the water is being soaking down, and the rate at which it's soaking down is much faster than the rate at which it is running down to the sea. Right? So the water is going to rise. So there's nothing no one can do about it other than wait until nature totally deal with this thing, until the water naturally flows away. The reason why you don't see it happen in recent years, because we merely have droughts, and we have not been getting as much weather system and hurricane system until recently. So over the period, if we are going to get rain in any substantial way over a protracted period, that area is going to be prone to water rising, right? And that is why I'm saying it is not feasible for those people to go back and live there. Because if it doesn't happen for the next 10, 15, 20 years, it's going to happen sometime in the future. All right? And if you sell that property, based on the history, no one is going to even purchase that property from you, because they do not want to face the same problem that you are running from. All right? So I hope that explains it. If you want, you can go through and look at the diagram here to give you a better explanation. You know, so it's a simple science. The water penetrate up the hill at a higher elevation. The water soaks down and it runs down the hill and it plateau in a little natural basin there. And we have worked this out. This is not anything new that we have I'm speaking about, because when I was working at the National Works Agency too, that is the conclusion that we have all come to. And based on my understanding of how hydraulics and how water operates, I know that is the case. The water just comes from all the hilly areas, from Christiana, Sparlins, Trelawney, wait a bit, all those highlands, and soak all the way down, and then they run down into that lower level, a lower basin, a lower valley. And because the underground aquifer is filled, because this area is filled, the water keep going up, up, up. And remember, it can't pass the bedrock here, because that is rock. And the water is not going to be able to penetrate the rock to go further down. So we just have to wait until the water runs naturally out back to the sea before we can have any resolution to the problems. But going forward, this is a recurring decimal. It's going to happen again whenever time we have protracted rainfall, because there's a natural basin down there, and the entire area is hill, right? And if it's hill, then there's no way the water have to run more than downhill, and it's going to settle where the land is level. All right. So I hope that explains it. It's a long time I haven't gone through something like this. So if you have any question, shoot me a question in the comment section, and I will see if I can answer your question. All right. Enough respect. Take it easy.